Okay, class, we're on number 10, our last problem for this lesson, and we're given here quite a bit of information that we need to analyze. If we pay very close attention to that information, we will be able to get the answers. We just need to rely on our formula that we've been given, y is equal to a over x, and we need to determine what values go where, but sometimes you have to realize that they're giving you information, and it's not necessarily that y is this or x is that or a is this. It's in the form of the words and the way they're describing things. And that's what happens in number 10. It says here that the time it takes to run the 100-meter dash varies inversely with the speed of the runner. Now remember, the time varies inversely with speed. Time inverse speed. Time goes up, speed goes down, speed goes up, time goes down. Okay, so that's what we mean by inverse. So A, copy and complete the following table for this quote 100-meter dash end quote function. They're putting quotes around there. They're letting you understand there's information here. They don't have to put the quotes there. They're telling you, but they're giving you just a slight hint. So we have a table and we have speed. So let's go ahead and put our table up here. We have speed and we also have time. So these would be like our x and y values. If we're comfortable with that, we can just put an x and a y here because we do have y is equal to a over x. We know that that's our formula and or our form rather. And so let's take a look at the information. Well, they give us 2 and 4, and then they don't give us anything here. We need to find that out. And then they don't give us anything for y, but the time they give us 20 and 10. Okay, so now you might say, well, Mr. Cartagena, we needed to have both so we can determine A. Well, let's take a look. They're actually giving you A when you look at what they're saying. It says it takes the time it takes to run the 100-meter dash. So they're already giving you the constant. The constant here is there's 100 meters in every single one of these values. There's speed, there's time, and then of course there's the distance. Um, so if we were to look at the speed of 2 and of 4, you might say, well, the speed at what for what distance? That will help us to tell the time. So if we know that it's 100 miles, then we would put 100 in here as the A, and our x and y values are now going to be determined by that constant. The constant is 100. So let's take a look. Let's for 2, I would put the x value in, right? And that would be 100 divided by 2 would be 50. If I were to put in 4, 100 divided by 4, well, that would be 25. Now we're given the opposite. Over here, now we have to say, well, what is we have a y value of, say, 20, and that's going to be equal to 100 divided by x. Well, we can find what the x value is, right? What do we multiply by 20 to get x, or excuse me, to get a? So what do we multiply? That would be 5. So 5 would be the value for x, because 5 times 20 would be 100, or again, 100 divided by 5, which is really what we're looking at, but I'm trying to give you the association between these two, again, with this value. Um, and later on, we're going to see how we can even change our formulas so that we can do this naturally. Okay, so let's go with the last one. The value is 10. 10 is equal to 100 divided by what number? What would the x value be? Well, we know 100 divided by 10 would be 10, or 10 times 10 is equal to 100. Okay, so we have found the values for our table. The missing values were 50, 25, 5, and 10. Okay, so now we have letter B where we're asked to write a formula for this function, letting t represent the time and s represent the average speed. Okay, so we're going to use s for speed, t for time, and uh, naturally we could just go ahead and fill in the x and y values. Okay, we could say t instead of y, right? T is equal to the time that it takes. A would be actually the distance, right? That's we already know. And the distance divided by the speed, that would actually give us the time. Um, I want to bring this all the way over to the other side of this board and sort of work with that. If we were to say then using t is equal to 100 divided by s, okay? Now we also know that we can represent speed, all right? What if it were speed? What if it were s? What would s be equal to? Well, we know that that speed is sort of like, let's say, miles per hour. Let's use we're very familiar with miles per hour. Another way to write that would be miles divided by the hours. How many miles for each hour? So if I were traveling 50 miles per hour, that would be 50 divided by 1 hour. That means I'm traveling 50 miles per hour, okay? So how could we then represent s is equal to the speed? Well, that would be 100. That would be the miles, or in this case, we use meters, and the time that it takes, which we're representing in seconds, okay? So we can write either time is equal to 100 divided by s, or s is equal to 100 divided by t. And what you're seeing is that these are interchangeable. You could move one back and forth. You can flip the s into the t and the t back into the s. We'll explain a little more how you're able to do that mathematically and how you're able to change an equation. But I just want you to be able to see that you can actually write two different formulas here relating to both the time and the speed. And if you did your math and you plug in your numbers, you would see how that relationship is clearly established in the numbers. Okay, now we're on the last one. In 1997, the women's world record time for the 100-meter dash held by Marlies Olsner of East Germany was 10.88 seconds. What could you conclude about her average speed? Okay, so, well, we have the time that it took. Well, they're asking about the speed, her average speed. And we could just go ahead and I'm going to point this up here and we're going to say that it's a 100-meter dash. So we can say that her speed is going to be equal to 100 divided by 10.88, which is the time that it took. So what would her speed be? Well, if we do our math, we would divide 100 by 10.88, and that would give us 9.19, and that would be meters per second. Okay, so I'm running out of room here. They would actually write it something like this, meters per second, or you write the word m per s, or meters per second. Okay, so we can say that her average speed was 9.19. And that's the end of our exercises.